Welcome to today's episode of Tech Talk, where we dive deep into the fascinating world of programming and software engineering. I'm your host, and today we're exploring a captivating topic, parser combinators. Now that might sound a bit technical, but trust me, it's a lot more interesting than it sounds, especially if you've ever tried to make sense of raw data or write your own parsers. So let's start by unpacking what a parser combinator is. In simple terms, a parser combinator is a way to build complex parsers by combining simpler ones. Think of it like assembling Lego blocks. You have different pieces, each capable of parsing specific patterns, and when you put them together, you can parse something much more complex. It's all about reusability and composition, making your life easier when dealing with data. Now, why is this important? Imagine you have an input string, say a simple sentence like tempus fugit. With parser combinators, you can describe the structure of your input in a very descriptive way, allowing your program to understand and extract meaningful information without writing a parser from scratch every single time. For instance, the parcom library, which takes inspiration from Haskell's parse and Rust's nom, operates directly on strings. It's strictly zero copy, meaning the extracted substrings are not reallocated, enhancing performance. Great for applications that demand speed. Let's dive into how this might play out in practice. Suppose you're tasked with parsing dates in various formats from user input. With parser combinators, you can define a simple parser for different components like day, month, and year, then combine these to build more complex date formats. But before we geek out too much, let's explore some intriguing examples. For instance, if we wanted to parse a string to find the word tempus, we'd use combinators such as string, which directly matches specified text. If it succeeds, it returns what we wanted. If not, we handle that failure gracefully without crashing the whole program. One of the key components here is how we handle whitespace. The parcom library allows us to define parsers for spaces, new lines, and even custom whitespace using utilities like space and multispace. This means you can segment your input cleanly, ensuring your parser only processes relevant parts of the string. Now here's a thought-provoking question for our listeners. Have you ever thought about how many layers of parsing occur in our daily technology? From the simple text in emails to complex JSON structures in web APIs, parser combinators play a pivotal role. And it doesn't stop there. Let's talk about the ability to create your own parsers through parameterization. Imagine writing a parser that recognizes excited apples, neatly defined and reusable whenever you need to detect excitement in fruit. It showcases that once you have your basic parsers in place, the sky's the limit. As we wrap up today's episode, let's reflect on some key insights. Parser combinators simplify the process of developing complex parsers by allowing you to build them from smaller, reusable components. They're efficient, flexible, and can significantly enhance how we handle data in our applications. Thanks for tuning in to Tech Talk. If you've enjoyed our discussion about parser combinators and want to explore more about programming techniques, stay with us for our next episode. Until then, keep coding and keep curious.